We all hear about the cloud every day, right? But when was the last time you really stopped to think about what that actually means? When you upload your files to Google Drive, stream a movie on Netflix, or make a Zoom call to a colleague, where does your data go? It's not just floating up into some magical sky. Instead, it's traveling through a complex web of servers spread out all over the world. And these servers, which are critical to how the internet works, are keeping us connected, informed, and entertained. In today's video, we're going to take a look behind the scenes and explore the cloud, backup servers, and load balancer servers, the technologies that keep your favorite apps and websites running smoothly. These are the unsung heroes of the internet, and by the end of this video, you'll have a complete understanding of how they work. You'll also get a sense of why the cloud is not just the future of technology. It's already here, shaping the digital world we live in. So buckle up as we explore cloud computing, data backup, and load balancing, and how these technologies are shaping the future of the internet. Part 1. What is the cloud, really? Before we dive deeper, let's address the elephant in the room. What exactly is the cloud? It's a term we've all heard, but it's often misused or misunderstood. When most people think of the cloud, they imagine a big digital storage system floating in the sky, but the cloud is far more technical and complex than that. In reality, the cloud refers to a vast network of physical servers, massive data centers full of racks of computers that work together to provide services like storage, computation, networking, and much more. These servers are located all over the world in specialized facilities known as data centers. So when you upload your photo to Instagram or send an email through Gmail, your data doesn't just travel to a single server on a local network. It's processed, stored, and sometimes replicated across multiple servers in data centers. Here's where things get interesting. Cloud computing is scalable, which is one of its biggest advantages. Let's say your website has suddenly gone viral. There's a flood of traffic hitting your site. With traditional on-premise servers, this could cause a massive crash because your server might not be able to handle the sudden spike. But with the cloud, additional servers can be instantaneously spun up to handle the extra load, and they can be just as easily scaled down once the traffic dies down. Scalability in the cloud is what allows businesses, even startups, to grow fast without worrying about investing heavily in hardware. Cloud platforms such as Amazon Web Services, AWS, Microsoft Azure, and Google Cloud provide flexible, pay-as-you-go infrastructure that allows users to only pay for what they use, whether they need more storage, computing power, or bandwidth. The cloud is far more than just a convenient storage solution. It's a way for businesses and individuals to access powerful computing resources without owning the hardware or managing the infrastructure themselves. Part 2. Backup servers, the guardians of your data. Imagine this: one moment, everything's fine. Then disaster strikes, your computer crashes, your website gets hacked, or even worse, your important data gets corrupted or deleted. Without backup servers, all of that information could be lost forever. That's why backup servers are so important. They function as your data safety net. Backup servers continuously duplicate critical data and store it securely in a separate location, often in cloud-based storage or remote data centers. These backup systems ensure that if something goes wrong with the primary servers, whether it's data corruption, accidental deletion, or a cyber attack, you can easily restore the original data from the backup. Essentially, they keep your digital life safe. Modern backup servers don't just store data in a single place. They replicate your information across multiple servers or locations to increase redundancy. This means that even if one server fails, there are copies of your data available elsewhere. And because many backup servers are now cloud-based, this adds an extra layer of security and accessibility. You can access your backed up data from anywhere, at any time. The types of backups available also vary. There are full backups, which copy everything on the server, incremental backups, which only save changes since the last backup, and differential backups, which save changes made since the last full backup. These varying backup strategies give organizations and individuals the flexibility to choose how frequently they back up data and how much storage they want to dedicate to their backups. But here's the kicker: backup servers don't just restore data after a failure. Some modern backup systems are intelligent. They can detect anomalies in your data, like a sudden unexpected spike in deleted files, indicating a potential ransomware attack. In this case, the backup server can automatically restore your files before they're completely wiped out. It's no wonder that backup servers are often considered the unsung heroes of the digital world. Without them, we'd all be at the mercy of our hardware and vulnerable to data loss. Part 3. Load balancer servers, the digital traffic controllers. Let's face it, no matter how fast your website is, it can't handle unlimited traffic on its own. So how do websites like Amazon, Netflix, or Facebook handle millions of visitors at the same time without crashing? Enter load balancer servers. A load balancer server is like a digital traffic controller. It sits in front of multiple web servers and distributes incoming traffic evenly across them. The goal is to make sure no single server is overwhelmed with too many requests, while maximizing the efficiency of each server. Without a load balancer, a website could experience massive slowdowns or even complete failure during traffic spikes. If a single server tries to handle all the requests, it can become bogged down and eventually crash. But with load balancing, the traffic is automatically routed to the most efficient server, ensuring that each request is handled quickly and the website stays up and running even during peak traffic times. Load balancers can also monitor the health of your servers. If one server goes down, the load balancer will automatically reroute traffic to the remaining servers, keeping everything running smoothly. This is why major websites can handle massive volumes of traffic without any noticeable downtime. For example, imagine you're watching a Netflix show. Your streaming request isn't sent to just one server. It's dynamically routed through multiple servers to ensure that the video loads fast and without buffering. The load balancer ensures that your request is sent to the best server in terms of speed and availability. Without these traffic controllers, the internet would be much slower and prone to crashes. They provide the performance and resilience needed for modern websites and services, making them critical to keeping the digital world running smoothly. The big picture: how these servers power the internet. Now that we've broken down each type of server, cloud, backup, and load balancer, it's clear how they work together to form the backbone of the modern internet. The cloud allows businesses and individuals to scale their operations instantly without the need to invest in expensive hardware. Cloud computing makes everything flexible and on demand, enabling a truly global reach. Backup servers ensure that no matter what happens, whether it's a cyber attack, technical glitch, or human error, your data is safe and recoverable. Without them, the risk of losing your files, images, or documents would be far too great. Load balancers then make sure that your website, app, or service performs well no matter how much traffic it's receiving. By distributing requests evenly across servers and ensuring continuous availability, they help websites stay responsive and minimize downtime. When combined, these servers provide the scalability, security, and resilience needed to keep everything online, fast, and reliable. They're the silent workers behind the scenes, ensuring you have a smooth online experience no matter what you're doing, whether it's uploading photos, streaming videos, or working from home. So is cloud computing the future? The truth is, the future is already here. Cloud computing has changed the game, and it's here to stay. The cloud is driving the digital transformation across industries, enabling businesses to innovate and scale at unprecedented rates. The future is not just about faster internet or better storage. It's about creating a more efficient, reliable, and flexible infrastructure that can support the explosion of connected devices, AI, and data. As the internet becomes more complex, the need for cloud servers, backup servers, and load balancing will only grow. The future of the internet is a connected ecosystem where cloud servers power everything from e-commerce and gaming to healthcare and remote work. And as technology advances, we'll continue to rely on these technologies to connect, protect, and scale our digital world. If you found this video helpful and informative, don't forget to like, subscribe, and hit the bell icon for more breakdowns on the tech that powers your everyday life. Got any questions or thoughts about cloud servers, backup systems, or load balancers? Drop them in the comments and I'll be happy to dive deeper. Thanks for watching, and remember, stay curious, stay connected, and never stop learning about the technology that shapes your world.